Welcome to my probability and statistics project. The title of my project is Unlocking Insights, a statistical dive into student performance trends, which was a survey performed upon US high school students regarding their academic performance. These are the parts we're going to be discussing in our presentation. So first of all, let's start with a formal introduction of my project. While talking about the objectives of my presentation of my project, the main objectives that we have in mind were understanding how different factors affected student performance and then performing different types of analysis and at the end deriving valuable insights that could be of help and could bring effect to our society. So first of all, let's discuss our dataset. The dataset consisted of numerical values, marks scored by different US high school students in different subjects, namely mathematics, reading, and writing. And then there were the factors that affected the scoring. So this is the sample data. As you can see, the first five columns are the factors that affected the latter. The three columns include having the numerical scores of different stat subjects. This is a data description that I have already given to you. So move on. Before performing statistical techniques on our dataset, we had to make sure the dataset was in a format that was usable. We had to make sure there were no null values and the outliers were dropped. So to make sure that our results were not skewed and were not biased. So we performed data processing. As you can see in the box plots here, that we plotted the outliers that were present in our data. The middle line in the dot plot is the median, whereas the areas surrounding are interquartile range, and then the circles beside the graph are the outliers present in the data. The data was pre-processed. First of all, if there were any missing numerical values in the data, they were filled with the mean of the column, and then we calculated the z-scores and calculated the z-scores, and based on the z-scores, we dropped any rows having outliers. If the z-scores are greater than 3, this means the data is an outlier. So after data processing, as you can see, there were almost none outliers in our data, and we checked there were no missing values and there are no outliers in our data. So let's move on to descriptive analysis of our data. So first of all, we performed basic calculations to check the central tendency and measure of dispersion. The central tendency was calculated to get a figure to represent the whole data, whereas measure of dispersion was calculated to get the spread of the data. So as you can see here that we have calculated different measure central tendency, and the most suitable for this dataset was median and mean. So we will be taking median for now. As you can see, math score has a median of 66, and reading and writing scores have 69 and 70. So from this, we can deduce that math scores were a little lower than the reading and writing scores. And when we move on to mode, we can see the math score was 65, whereas the highest scores in reading and writing were 72 and 74. So it shows us that people score relatively low in math scores, whereas in reading scores and writing scores. And by checking the variance and standard deviation, we can see that our data was validly spread over a large range. Then we calculated the skewness, kurtosis, and moments. So as you can see from the values, the kurtoses were negative, slightly negative, showing that some students were able to score exceptionally high, whereas the skewness is almost close to normal, suggesting that our data was normal, hence our preprocessing was a success. Then move on to how our data was distributed between different actors. First of all, is the randomized distribution Almost 48.2% were males and 51.8% were female students. This is the distribution race-wise. The Group C had the largest contribution, whereas the Group A had the least. Parental education-wise, most of the students had parents had some college degree or associate degree, whereas relatively very low percentage had master's degree, which was 5.9% of the data. Then test course-wise data distribution, almost 36.1% students completed the test preparation course, whereas the other 63.9% did not. The learn for data distribution, 35.2% students were offered free or reduced lunch, whereas 64.8% had the standard lunch. This is the average score comparison. So from this, we can see that reading scores and writing scores are higher than our math scores, as we concluded from the mean and median scores. And this is the same as that of math score is around 65, 56, whereas the reading and writing score are around 71, 72. So now let's move on to explorating insights and deriving relations. First of all, let's talk about how different factors affected our test scores and what were their average results. So, based upon gender, we can see that females were able to score on average higher than males, whereas male students were able to score higher in maths on average. So we can conclude that on overall basis, females were able to score higher, whereas on math basis, males were able to score higher. Then on test preparation course wise, we have a noticeable difference that students who completed the test course preparation were able to score noticeably higher. Then we have the average test scores based upon learns and parental level education. So if we observe parental level education, we may see that the data is scattered. We may not be able to deduce a proper insight, but still there's a weak relation that exists between the two. Though the more the education background of the students, of the parents, the students were able to score a little higher. But this is a weak relation, and there is not a proper relation present here. If we talk about lunch wise, the students with standard lunch were able to score higher than those with free. Average test score by race. So by race, we can see that race has a significant effect on our test scores. The group B were able to score higher than all of the other groups, and group A had the lowest. Now we perform the OLS regression model on math scores to get the p-value of the factors to understand how different factors and how significantly different factors affected our test scores. As we can see, all the other scores, all the other factors except for parental of education have p-value 0, which means they were highly significant in affecting the test scores. Whereas the parental of education was not that significant, was a weak relation, as we have already deduced from the graphs. And we have the correlation matrix to understand how different scores had relation with different scores. As you can see, if a student scored good in math scores, it was 81% probability that he would score good in reading and 79% in writing score. Whereas a student who has gotten good score in reading had an 81% chance of getting a math score and 95% chance of getting good score in writing score. So from this correlation matrix and the heat map, we can deduce that reading and writing scores are correlated with each other, whereas math does not is related, but it's not that much directly related. Students who are getting good marks will get overall good marks in all the subjects, whereas students who are getting good marks in reading or writing will get the good marks in other subjects as well. Whereas if one student has gotten good marks in math score, it does not mean that he will also get good marks in reading and writing. So now we talk about some concluded insights we have gathered from the data processing. First of all, our data performance trend shows that the data was normal and it was consistent across the data spread. The data was balanced and it was consistent. All the factors except for parental level education greatly varied the test score result. And the strong correlation existed between writing and reading scores, whereas it wasn't that much significant in math scores. So we were faced some challenges while we were working upon our data set. First of all, the data set had to be cleaned and pre-processed to make sure there were no missing values or inconsistent or anomalies in our data set, and removing any outliers based upon the z-score. And then even after cleaning the data set, we were facing some skewness. So we had to carefully reduce the partitions while making sure the student didn't affect that. And at the end, we had to make regression analysis while making sure correlation and multicollinearity did not affect the regression model. So this was my presentation. For now, let's move on to our code. Use process the dataset. First of all, we imported all the libraries and then we checked if there were any potential problems in our database by checking any missing values or outliers. And the outliers were checked by z-score. If any value had a z-score higher than 3, it was checked and taken as an outlier. And then we visualized the outlier using box plot. This here is the median, this is the IQR, the interquartile range, and these are the outliers within our score. And then we cleaned the data set. We filled the missing columns, missing cells with the mean of the column, and we handle the data outliers by only selecting the column that had the z-scores smaller than 3, hence making sure no outlier was present in our data set. And then we again visualize our data set to check if we were able to successfully remove outliers from our data. Here you can see the outliers have been removed from our data. And then we performed the calculations on the ungrouped data. We calculated the tendency, the variance and standard deviation, the range, quartiles, percentiles, deciles, quartile deviation, mean deviation, kurtosis and skews, the moments around the origin, coefficients of variance. And then we made a dictionary to store all the results. And at the end, we made sure to display all the columns and rows of the data. And then we simply converted our dictionary into a panda frame, and then we displayed the transpose of the data, of the result that we got from the calculations. And we have already discussed these in the presentation. And then we made the data distribution graphs. Used the for loop to make sure that every data distribution graph was made automatically. Here you can see. And then at the end, I wrote this code to make for numeric columns and to get the mean scores, the average score of each subject. And we have already discussed this distribution of data. And this was in this part of code, I grouped the numerical columns by a factor and then showed it, which we have already discussed in the presentation. This shows how a factor affected the scores. Then we converted the data into frequency distribution or group data, and then we again performed the calculation upon grouped data. We got a result column, and then we converted this into a panda frame, and then displayed the data. The data was almost exactly the same as for ungrouped. And then we made the histogram, frequency polygon, and OGIF for our math scores, reading scores, and writing scores. This here you can see the code. We make sure to use the axis 0, axis 1, axis 2 to make sure for a specific subject all the graphs were be plotted in the same line. And we use the for loop to make sure that every subject was calculated for. Here a sample of data is being shown, and by using this code we calculated the correlation matrix which I used the SNS function heat map. Here I calculated the OLS regression result, which I've already shown you in the presentation for checking the p-value of our calculations. Thank you for listening to my presentation. This was all. Thank you.